All right, so we are talking congruent vertical angles. So a couple of things are packed into this. You actually already sort of experimented with these angles a little bit yesterday in the homework, whether you knew that you did or not. So what I want to do is sort of recap one type of problem from yesterday and sort of see if we notice anything. So one style of problem that you had yesterday, you had two lines that sort of cross like this, and then they gave you one angle, and then you were asked to find two others. So someone shout out a number between 1 and 180.
86.
86. Okay. Let's say this angle right here is 86. I'll pick that one. And I think on the homework you had to like solve for those two missing angles, something like that. So for angles A and B, okay? So check this out. What we had done yesterday was we said, okay, well, take a look at those two angles right there. Those two angles, 86 and angle A, they are a linear pair. Those are supplementary. Those two together are going to add up to be 180, right? So you could find angle A that way by doing 180 minus 86. And what's that, 94? So, great. Okay, now I know that angle A is going to be 94 degrees. Perfect. Okay, and then you did the same thing pretty much to find angle B. If I just look at those two, right? So the one that's marked 94, or angles A and B, right? That's another linear pair. Those two together add up to be 180. So to find angle B, I could just do 180 minus 94. And what does that get me? Well, lo and behold, it gets me 86, doesn't it? So what's interesting about this is that you may or may not have noticed, oh, look, I get the same number across from each other like that. Huh. What you didn't have to do in last night's homework was you didn't have to find this fourth angle, but I'm curious. Let's find it anyway. So if I kind of played the same game, if I look at these two angles here, that's a full 180 degrees, right? That's a linear pair. So again, I would do 180 minus 86. What? 94. That's weird. Or is it? Look what you see here. I have 86 here, 86 here. I have 94 here, 94 here. So the people across the way always seem to be equal to each other. Now, I ask you, is that a fluke or is that going to happen every time? What do you guys think? Did it just so happen to work out this way? Because 86 and 94, I don't know, maybe there was something special about them. What do you guys think? Is this going to happen every single time, no matter what the numbers are? I think so too. I think so too. I'm going to do one more real quick. Someone give me another, pick any number you want between 1 and 180.
74.
74. Okay. If this one's 74, let's see if the same thing happens. So if you're 74, right here, these are a linear pair. So 180 minus 74, isn't that 106? So you're 106. Okay, let's keep going. If you're 106, these two add up to be 180. Holy smoke. So yeah, that's 74. These two add up to be 180. Oh my gosh. Wow. Okay, so we could sit here all day and literally test every number between 1 and 180. But the problem comes in when you say, okay, well, what about, what if you included what if your original angle was like 75.9? Which it certainly could be. You can have decimals of angles. Did you know that? You can. You can have decimals of angles. So there's no way that you could test every single number between 1 and 180. It's impossible, right? Because there's an infinite number of numbers in between 1 and 180, because you can keep adding another decimal for forever. So how am I supposed to prove to you that this is true all the time? I'm going to show you how to do it using a variable. So you don't have to write this down. This does get a little, I mean, it's a little weird algebra stuff, but I do think it's important for you to see how you can prove something to be true all the time. Because right now, I've only proven it to be true for this set of numbers and for this set of numbers. I want to show you it works always. So here's how I do it. I'm going to, again, you don't have to write this down, but just try and follow along with me here. Because it's really kind of cool. And this is sort of how you prove things are true in math for all cases, because you can't possibly test every single number, right? It's just impossible. So let me show you what we can do. Let's say I just said that the first angle is x. And I'm just going to specify that x does have to be in between 0 and 180. So this is saying you pick any number you want in between 0 and 180. I don't even care what it is. Could be a decimal, could not be a decimal, don't care. You pick anything you want. All right, watch this. To get this angle, don't I always just do 180 minus this number? So remember, just like we had it yesterday in our chart, if these two are supplementary and my first angle is x, isn't this one just 180 minus x? Right? Remember that from yesterday in the chart? Right? Yes. Those two together add up to be 180. Now, this is where it gets a little funky. Now, follow me on this. This angle here, isn't it just going to be 180 minus whatever that one is? Right? Isn't that how I did this all the way through? Right? Look, I started with 86. I did, to get this number, I did 180 minus that. Got this. So then I came over here. I didn't know what it was yet. To find it, I did 180 minus that. I'm going to do the same thing for this. Check this out, okay? Watch with me. I'm going to do 180 minus all of this. So just like we practiced yesterday, I would need to put that in parentheses. And I know what you're thinking, like, what the heck is that? Watch when we simplify it. Are you ready? Are you watching? I hope so. So distribute that negative. You get 180 minus 180, but now be careful. When I distribute that negative, minus a minus turns into a plus. What's that really? 180 minus 180 just cancels itself out. Get out. You're just left with x. Look, it is the same. The two across the way really are the exact same thing. No matter what you pick for x, which also means this very last one, aren't I just going to do 180 minus this? You bet I am. So look at that. These two across the way are going to match. These two across the way are going to match. Always. As long as you have a diagram like this, this is always going to be true, no matter what the numbers are. I know, this is super exciting. Oh gosh, Mrs. Savia, I wish we had a word that described those angles across the way. I wish there was a vocab word that sort of summed that up. I thought you'd never ask. You know there is. They're called vertical angles. Okay? Now, I know it's a little confusing because vertical in everyday language means up and down, and vertical angles kind of really don't have anything to do with being up and down. Right? Because look, these two are like side to side. Sure, these are up and down, but these aren't. They're side to side. So it's, I know, I don't love that it's the same word that means something totally different, but it is what it is. Okay? So I'm going to write the official mathy wordy definition just so that you're familiar with it, so that you've seen it. If they ask you, you know, if it's in a matching section on the MCAS or something, you've seen the words, you can match them up. And then, but I personally think that vertical angles are much easier to understand just by looking at pictures of them. All right, so let me give you the mathy definition and then we'll draw a bunch of pictures. All right, here we go. Vertical angles. They are as follows. Oops, there we go. They are two angles with a common vertex, so that is required. They have to have the same vertex. Two angles with a common vertex. Let me zoom out a bit. whose sides form opposite rays. What? That sounds so confusing. I don't even know what that is. Yes, you do if you break it all down. All right, two angles with a common vertex. So, of course, they have to, here, let's draw one at the same time too. That might be helpful. All right, so here's what I need. Let's take a look at angles 1 and 3 and see if they follow what is set up here. Angles 1 and 3, don't they share a common vertex? They sure do. They both have this center point as their vertex, got it. And now they're saying the rest of this, whose sides form opposite rays, okay? So if you remember way back when to chapter 1, opposite rays do this. So here's a ray. It has a definite endpoint and it goes on forever in one direction. To form an opposite ray, you start at the same point and you go in the complete opposite direction. So what's it really look like? A straight line. Okay, so I know straight lines get very confusing because now we have so many different ways to describe this thing. You can just call it a line. You could call it a straight angle. You can call it opposite rays. It's all the same thing. Ugh, frustrating, right? I know. There's so many different ways to say the same thing. Why? I don't know. I wish I could tell you. I like simplifying things myself, but it's not up to me. So I got to familiarize you with all the lingo. All right, so any Hoosers, let's see if angles 1 and 3 actually do that. So if I take a look, here's the side of 1, and yeah, it does make an opposite ray with one of the sides from angle 3. So see how these two together make a straight line? And then I just check and make sure that it's happening on the other side too. So here's the other side of angle 1. Yep, runs right into the other side of angle 3. They absolutely do form opposite rays. So what does that mean? That means that angle 1 and angle 3 we can call vertical angles. And as we just proved up above, vertical angles, the ones that cross from each other, look, not only are they called vertical angles, but they're equal to each other. So their measures are always going to be the same. This one, 106, matches this one, 106. Oh my gosh. So this is like a huge deal. A massive, massive deal. It's so massive that I'm not just going to star this. I'm going to fireworks this. So please make a big star. And when okay, so I've got this. Oh no, did my camera freeze?
Yeah, just.
For Pete's sake. I wonder who Pete is.
Good run.
Yeah. There we go. All right. Look at that fireworks I'm starting, right? It's not just the start. It's, look, I'm even doing multicolor because it's so important. Really big deal here, okay? So what's the big deal? The big deal is that vertical angles are always equal. This is the ultimate buy one, get one free sale. I cannot stress this enough. So if you know that angle 1, for example, is 30 degrees, you automatically know that angle 3 is 30 degrees. You don't even have to do any math anymore. If they are across the way from each other and they're vertical, so make sure that they really are vertical angles, they're equal. It's so nice. But hold on, it gets better. I feel like an infomercial. Wait, there's more. Check this out. Look at this diagram. There's another pair of vertical angles in there. Do you see them? Right there, 2 and 4. You get another pair, another buy one, get one free sale. Oh my gosh. If I know the measure of that angle, I automatically know the measure of this angle. I don't even have to do any math. there's another pair of vertical angles. They're automatically going to be equal to each other. Oh my goodness. This is so cool. There's two things, though, that I need to caution you on with vertical angles. Let's see, where do I want to stick this? I think I'm just going to do it on the next page. So I need to flip, but I'm hoping that everybody got the most important fireworks here. Did you mark it? Even if you don't have multicolored markers, that's okay. Give yourself something to draw your attention to that statement that vertical angles are always equal, because that's going to be the driving force for the whole lesson here. All right, so now let me show you what vertical angles are and are not. So I'm going to start off with a star right here, and I'm just going to remind you, or I guess not remind because I've never told you this, but vertical angles can never be adjacent. There can never, ever, ever be next door neighbors. So if you have two angles that are literally next door neighbors that are adjacent, they don't count as vertical angles. They can't. It's impossible because their sides could never form those straight lines. Okay, so that's important to remember. Okay, and here's the other type of way that we can try and trick you with vertical angles. Something like this. Say I had this. Okay, yep. I'm just going to number all my angles here. 1, 2, 3, 4, and 5. In this diagram, I have one very clear pair of vertical angles jumping out at me. I hope you see it too. Speaking of two, that's one of them. So 2 would be vertical to angle 5. See that? See how their sides make that nice X? Okay, they're right across from each other. They share a common vertex. They have everything that I need. Here's where it gets a little tricky, and sometimes kids fall into this trap. Let's talk about angles 1 and 4. Because I know, I get a little lax and I say, oh yeah, your neighbor across the way. So it feels like 1 and 4 are neighbors across the way, but they're not technically vertical angles. So let's talk about why not. They do share a common vertex, I will give you that, but their sides don't form straight lines, right? This one does. If I trace this one, here's the side of angle 1, and yep, it runs right into a side of angle 4. That's a straight line. Yep, got it. But then if I do the same thing with the other side, here's the other side of angle 1, and then look, to continue along angle 4, that's not a straight line at all. The straight line would have been this way. Do you see that? So there is another vertical angle pair, but it's not 1 and 4. Same thing happens with 1 and 3. Here's the other vertical angle pair. Are you ready? 1 and this whole angle. It'd have to be the two of them together. So it's not just angle 3 or just angle 4. It would be the whole angle. So I'd have to name it with letters like ABC or whatever. Okay, be careful. I just wanted you to be aware that it is possible that you have these angles that kind of feel like, oh, maybe that's vertical. They have to make an X with each other. Look for the X. Two straight lines that are crossing, and then it's your across the way neighbors. Okay, let's do some numbers now. Or yeah, I'm gonna throw in some algebra. You ready? I think you're ready. Let's try it. Let's see what happens. We'll start off easy. Let's say this is 120, and let's say this is 7x minus 20. So you ask yourself, are these two angles vertical? I say yes. And then you think back, okay, what was that giant fireworks thing that she made a big deal about? Oh yeah, it said that vertical angles are always equal. You have enough information to write an equation right now. Would anyone like to share theirs?
120 equals 7x minus 20, or 7x minus 20 equals 120.
Yep, same thing. Either way. Guys, you literally just set them equal to each other. That's it. You don't have to worry, what does it add up to? Is it 90? Is it 180? We don't care. It doesn't matter. Vertical angles are equal. This is why they are my favorite type of angles, because they're so easy to deal with once you understand that that's all you do. So just make sure you have a pair of vertical angles, and then you write the equation. That's it. You just set them equal. This is so awesome. Now, all I got to do is solve. That's easy. I can solve this all day long. Add the 20, add the 20. You get 140 equals 7x. Divide both sides by 7. Bam. Look at that. Psh. Miss Sabia, I thought this was going to be a challenge. Not for you, you Tantasquin. Look at you go. Same as yesterday. This is what I'm going to want to see on the homework. Okay, let's try another one.
Hey, you want to give them a challenge? Completely throw them. Instead of using an X, use a Y.
Ooh, good idea.
Changes the whole dynamic of what you write. And that's about it.
Okay, let's try this. What if I did, how would I put it in the screen first? That would be helpful. Let's do 7y minus 10 and 6y plus 15. Try that. Okay, someone share with me your equation. Nobody? I got my popsicle sticks, don't worry.
7y minus 10 plus 6y plus 17 equals 180.
Are they supplementary though?
No, we don't know that yet.
Right, so you can't write an equation that says that they are. What do we know about them? What kind of angles are these?
Vertical angles.
Yes, they're vertical. So think of what we just, wait, what'd you say?
7y minus 10 equals 6y plus 15.
That's it. You literally just set them equal to each other. You don't even have to think about what they add up to, none of that. So just 7y minus 10 equals 6y plus 15. If you know that you have vertical angles, that's all you got to do.
Vertical angle?
Vertical angles. Is that what I said? I meant to. I might have misspoken. Now I just got to solve this equation. So let me zoom in a little bit and just make sure we're okay solving this. When you have variables on both sides, right, you need to get them together. So me personally, I would minus the 6y, because 7y minus 6y is just a positive 1y. If you minus 7y, you're not wrong, but now you have 6y minus 7y, and now you have a negative. Don't make it harder on yourself if you don't have to. So it is a little bit easier if you just minus 6y from both sides. It's not wrong. It's just, you know, do you want to deal with negatives if you don't have to? I don't want to. And now all I got to do is add 10. See that? And I'm done. That's it. That's my answer. Y is just 25. Psh. That's all I got to do.
Are you eventually going to make it so we have to like find the angle measure and just with angles like this? So like y, 7y minus 10, and then you're going to ask to find the measure.
I don't know off the top of my head, but let's do one where I do ask you to find the measure. Let's do one more. So let's give you some of these. Oh, that's Whatever. We'll make it work. Let's say this is, let's make this 2y minus 4. And let's make this y plus 7. And now, ooh, I know. Let's put a little, gosh. All right. Angle 1 right here. So here's what I want you to do. This one's like a two-parter question. I want you to solve for y and then find me the measure of angle 1. Okay, so step 1, solve for y. Step 2, find the measure of angle 1. Ooh. That one's interesting. So the first step should be pretty straightforward.
Yeah, you
Hopefully
guys, you've already done that. It's the same process. We did it at the beginning of the class.
Let me. Sorry, just trying to cover this up so there's not too much on the screen at once. Okay, so solve for y, same way you have been.
This is a good brain teaser, Miss S.
I can't even take credit. Who even told me? Who was it Riley or was
No,
it Steve?
Steve asked the original question, will we eventually, or Riley did,
Oh, good.
will we
Yeah.
eventually find angles? But this is a good brain because it's taking that one step further than what they've been doing, just doing the basic process. So
All right.
tying it.
So who's got an equation to solve for y for me?
Two y minus 4 equals y plus 7.
Yes, those two are vertical angles. So I'm going to set them equal to each other. And I'm going to solve this equation. And then I'll be done with the first part, right? So let's see. I would minus y from both sides. So I get y minus 4 equals 7. And then all I have to do is add 4, add 4. Okay, great. Now, they want the measure of angle 1. Oh, sorry. I'm off a little bit. So great. I know that y is 11. Remember, the drawing is not to scale. Nothing is to scale. But if y is 11, I should be able to find the measure of angle 1. Does anybody, I guess, hold on. Let me get my answer.
Do you want me
Hold
to
on.
answer or are you doing sticks?
Wait, what did you say?
I said, do you want me to answer how to do it or do you want to use sticks?
Oh, I thought you were giving me the answer of 66.
Oh, no.
I thought you said, do you want me to give you the answer of 66? I'm like, well, I think you just did, didn't you? But you didn't say 66 at all. All right, hold on. Let me get my answer. Okay, tell me your answer.
Of angle 1?
Yeah.
Angle 1 should be 72.
Ooh, we're close.
Because I added 11 to 7, which was 8.
You're right, and you should. So,
Oh, it should be 180, so it should be 162.
yes, 162. Did other people get 162? If you didn't, let's sort of recap where we're at. So, angle y, I'm sorry, y is 11, right? So if I want to figure out what the measure of this angle is right here, it's not 11. It's 11 plus 7, isn't it? So that whole angle is 18 degrees. I know it doesn't look like 18 degrees, but whatever. We go off the numbers, not how it looks. These two angles together, the whole thing, add up to be 180. So all I have to do to find the measure of angle 1 is 180 minus 18. And that's where the 162 came from. And that is correct. Obviously not drawn to scale, whatever. That's fine. Because we go off the numbers, not looks. Yay! Okay, good. So that's it for the notes. That's everything that I wanted to show you. and then some, I think. All right, so I am going to, does anybody have any questions right now before we pop on over to the homework? Okay, if you feel confident and you're ready to begin, it should be on Delta, ready to go. I am going to do out a few for anybody that wants some more support. Oh, except I gotta click in the wrong buttons here. There we go. Okay, so let's share this. Got it. All right, so when you come on in, you should see homework 18 at the top here. So very similar to yesterday, you're going to see that there's a bunch up at the top here that are pretty straightforward. They're just numbers. Then you'll see that I inserted my own question, just like I did yesterday, saying, hey, from here on out, I need to see your work. So for these top 3 things, I don't need to see work because it's just numbers. But, oh, by the way, this question, the one where it's just me saying, hey, from here on out, you need to submit your answers. If you don't do anything else on this homework, you should click this and hit submit because that counts as a right question. So it'll actually boost your grade if you click it and submit it. So hint, hint. There's some easy points right there. Look, I just got some. So any Hoosers, let's look. What? 5%? You get 5% just for doing that. That's why I had people that had 5%. Oh my gosh. I didn't even think of that. But anyway, well, you get a free 5% if you just click that one. Anywho, let's click one of these. Let me zoom in a bit. And I'll come over here to my iPad and we'll do one of these together. Let's get all that in. Okay, so this one is saying which number angle represents an angle vertical to VYU. So first of all, you need to make sure you know who angle VYU is. And remember how we do that. We're just going to trace. So I start at V, I go to Y, and I follow it off to U. So that means angle 6 is the one that they're talking about. They want to know who's vertical to angle 6. So in this diagram, the only one vertical to angle 6 is 4, right? The across the way neighbor. The sides make that nice X. Yes, so 4 is going to be my answer. That's the one that's vertical to the one they're talking about. VYU. Across the way is angle 4. So I come down here and I just pop in 4. Whoa. Okay, let's try. So I think you have 6 that are similar to that, just making sure that you know which angles are vertical angles and which ones aren't. So the next one is going to start incorporating some numbers here. Now, this one, I don't know what angles C and B are, but they're vertical. So guess what? Once I find one of them, I automatically get the other one for free. I don't have to do any more work. So I'm just going to have to do a bit of work to find, let's say, angle C first. But once I get it, I know that B is the same answer. I don't have to do any more work to find it. Yes. So how do I find it? Well, check out these two. Don't these two together add up to be 180? Right? Isn't that the full rainbow? Yeah. So I just do 180 minus the 103. So what's that? 77? Yeah, cool. So it looks like C is just 77, which means B is the same thing. I don't have to do any more work. All right, let's try another one like this because they're not, I'm going to show you like a little bit of a different style. All right, look at this one. Look at this one. This one, I already know the answer for B. I don't even have to do any math. I already know it. It's a free sale. If that's 70, that's 70. Because they're vertical angles. Oh, cool. So I get B kind of for free. Now, C is not the same this time, though. C is going to be different. So now I have to do a little bit of math to figure out what C is. So I'm like, okay, well, those two, there's my full rainbow, 180 minus 70. Okay, C is just 110. That's not so bad. Okay, make sure that you also submit the right angle in the right box. You don't want to put angle B in angle C's box and vice versa. All right, so did we do ones like this yet? No, we didn't. All right, then, ooh, I try and give you ones that are a little bit trickier. Remember, vertical angles are always the same, so check it out. I have these two, 75 and angle D. You already know the answer for angle D. You don't have to do any math. You know it. It's 75. Okay, cool. Got it. 75. All right, now E, be careful. Look, this is a straight line. This is a straight line. That means that these two really are vertical angles. Okay, so I know the answer for E. It's got to be 28. I don't have to do any math. This is amazing. However, F. Take a look at F with me. F does have a vertical angle pair. It's this one and this one. The problem is, oops, sorry. Oop, oop, oop. There we go. The problem is I don't know what either one of them is. So shoot, if I had known what that was, I would have gotten F for free, but it's not quite free because I don't know what it is. So, oh man, what am I going to do here? Well, let me show you. We do know that E is 28, right? We already found that out. Look what's happening here. Look at these. Isn't that the full rainbow? So don't all three of those together add up to be 180? You bet they do. So I can just do 180 minus the 75 and minus the 28. So I don't know what that is. $28. 77. So F ends up just being set. So yes, I had to do a little bit of math, but I only had to do it for one angle, not for three of them. Okay, so just be mindful of that. Vertical angles are going to save you so much time. Okay, let's get to the equation stuff. Oh, for Pete's sake, there we go. So again, just like yesterday, you're going to get to the one question from me that says, hey, you need to do your workout, blah, blah, blah. Okay, fine. So there's only 5 of them that you need to do. So let's take a look. You come in here, you see this. Oh, all right. Those are just vertical angles. I've got this, no problem. So if they're vertical, I'm literally just going to set them equal to each other. That's it. I just set them equal, and now I'm just going to solve this equation. This is not so bad. Divide by 8, divide by 8. 96 divided by 8 is 12? Double check me. Yeah, that's right. 12. And am I supposed to be solving for t? I believe so. Yeah, just says solve for the value of t. Great. So I'm done. I don't even have to do anything else. That's it. It's just 12. Huh. Mrs. Saber, you mean to tell me that it's that easy to write these equations? I mean to tell you that. I sure do. Check this one out. It's the same thing. They're vertical angles again. So I literally just set them equal to each other. 50 equals 6v minus 4. That's it. Now just solve. Okay, so I hope that this makes sense. A great check is that your numbers are coming out as nice whole numbers. If it's not a whole number, there's probably an error somewhere. So watch that you didn't drop a negative or add or subtract wrong. All right, because they should come out nice. All right, and yes, in real life, it's not always going to be perfect, but I'm telling you right now that on Delta, they are going to come out nice for this section, okay? All right, does anybody have any questions right now? We're all right? Okay, so I'm going to stop the video.